The internal rate of return of a project is equal to the rate at which the present value of a cash inflows is equal to the present value of cash outflows. In other words, at IRR, the NPV of the project is equal to 0. Since the viability of the project is presented as a percentage, it improves the communication, particularly if the final decision maker is not familiar with the DCF technique. The IRR computation is a bit tedious. We need to find out the NPV at different rates and finally narrow down the rate at which the NPV of the project is equal to 0. Microsoft Excel and other spreadsheet softwares simplify this computation. The Excel formula for computing IRR is equal to IRR and then cash flow range within the bracket. The decision rule is accept the project if IRR is greater than or equal to the cost of capital. If the projects are mutually exclusive, the decision rule is shortlist all projects whose IRR are greater than the cost of capital and then accept the project whose IRR is the highest in that one. Let us do an illustration. The production manager of Alpha Limited wants to add a machine and considering two machines to choose one of them. Machine A costs 10 million and generate a cash inflow of 2 million for 10 years. Machine B costs 12 million and generate a cash inflow of 2.5 million for next 10 years. Let us take the help of Excel to compute the IRR of both machines. The IRR of the machine A and machine B are 15.1 and 16.19 respectively. Since IRR of both machines are above cost of capital of 12%, both qualifies for investment. Since they are mutually exclusive investment proposal, the decision is in favor of selecting a machine B whose IRR is greater than IRR of machine A. In case of NPV, we said an investment of 12 million in a machine B adds a value of 2.13 million. In IRR, our interpretation is the project generates a return of 16.19% against the requirement of 12%. The difference is 4.19%. Most managers understand IRR quickly without any further explanation. In that sense, IRR scores better in communicating the project viability. If the communication for IRR is superior, why do we need to measure NPV? The reason is IRR scores better on communication but fails on few other issues. One of the major shortcomings of IRR is at times there are two IRRs and the decision maker may get confused. Sometimes the decision maker may not even know the existence of another IRR. The multiple IRR happens when the project cash flows have more than one sign change. They are called non-normal cash flows. Suppose you are taking up a mining project which requires an investment of 1000 million at time 0. It produces 3000 million cash inflow in year 1 and another 3000 million in year 2. Then you need to spend another 3000 million to close the mine. The project on the face of it is a great project because for an investment of 1000 you get 3000 at the end of 1 year. Whatever you receive in year 2 you will be spending in year 3 and then cancelled out. But if you use Excel to compute IRR, it returns a negative IRR of 34%. The answer is not consistent with your logic. You feel there should be another positive IRR. You can ask the Excel to rework this IRR by giving a guess value, say 30%. Your revised Excel specification is equal to IRR range of the cash flows, comma 30%, where 30% is a guess number and it returns an IRR of 260%. Though multiple IRR is a bit rare event, one should remember that it is possible when the cash flows are not normal. Another criticism for IRR is it assumes project cash flows are reinvested at the rate of IRR. In the above example, it is assumed that cash flows of year 1 and year 2 are reinvested at 260%. You can observe this implicit assumption in IRR equation where all cash flows are discounted at IRR. Just because we happen to hit a great project, it is not practical that we will get similar projects in future so that we can reinvest our cash inflows in those projects. Even if we assume that we get such super project, the question is why should we give the benefit of those projects to the current project? Practitioners today use a modified internal rate of return or MIRR to overcome this problem. In addition to cash flow details, we need to give the rate of borrowing and the rate at which we will be reinvesting the cash flows. We can assume both values are equal to cost of capital. If we compute modified IRR for the above mining project on the assumption that our cost of capital is at 12%, it shows 31.46%. We are skipping the mathematics behind this computation. Though IRR communicates well, the trouble is we end up in having 3 IRR for the mining project that we discussed above. Though such occurrences is rare, we need to be cautious while using IRR. We close our discussion on IRR with a simple solution. When you evaluate financial feasibility of a project, compute and report both NPV and IRR or modified IRR. Use NPV for decision making. Let non-finance user use IRR or MIRR for understanding of the project viability.